Somewhere in the darkness between stars, a quiet paradox waits for us. The nearest solar system is close enough to see with backyard telescopes, yet so far that no human has ever come within 1 trillion miles of reaching it. Alpha Centauri glimmers only 4 light-years away, a cosmic neighbor just beyond our fingertips. And tonight, we drift toward it, not with rockets or engines, but with imagination, drifting through the velvet sea of interstellar night. How long would it truly take us to get there? With our fastest ships? With future engines? With technologies we've only whispered about in theory? Like and subscribe before we begin. It helps this gentle cosmic journey continue. Settle in. Breathe slow. Let's begin. Alpha Centauri may feel impossibly distant, yet in the grand scale of the Milky Way, it is right next door. As we drift into the quiet of this journey, we begin by zooming out, seeing our sun as just one golden lantern among hundreds of billions, and Alpha Centauri as the closest friendly glow on the horizon. From this higher vantage, space no longer feels empty. It becomes a slow ocean of starlight, each point a distant shore with its own history, its own worlds, its own silent storms. The sun's warmth lingers behind us as a fading memory, while ahead, the faint glimmer of Alpha Centauri beckons like a lighthouse, guiding travelers through a cosmic night. Even though the distance between our two systems spans over 4 light-years, in the language of galaxies, that gap is barely a whisper. We are drifting between neighbors, quiet, ancient, and bright. The Alpha Centauri system is a trio of stars dancing through the dark. 2 of them, Alpha Centauri A and B, orbit each other in a slow celestial waltz, each tugging gently on the other as they move through space. The third, Proxima Centauri, wanders farther out, a dim red ember keeping its own pace. From where we float now, the 3 lights blend into a single soft shimmer, like a cluster of fireflies hovering above a summer field. As our mind eases into the rhythm of the journey, we begin to sense how delicate and interconnected the universe truly is. The gravity of each star pulls not only on planets and dust, but on time itself. Even light, the swiftest traveler in existence, must obey their command, bending slightly as it passes, curving like a river flowing around smooth stones. This subtle dance creates the cosmic landscape we move through, sculpting vast currents of emptiness and energy. Around us, the interstellar medium gently thickens and thins, a whisper-thin haze of gas and dust stretching between stars. It is so sparse that you could travel 100 kilometers before touching a single atom, and yet over millions of years, this dust becomes seeds, future planets, moons, comets, and perhaps even life. Tonight, it drifts by us like drifting snow, soft and weightless, catching the faint glow of nearby stars. Ahead, Alpha Centauri brightens. At first, it looks no different from the countless specks around it, but slowly, its twin nature reveals itself, 2 stars circling each other in an eternal embrace. Alpha Centauri A, a bit larger and brighter than our Sun, shines with a calm, steady brilliance. Alpha Centauri B, slightly smaller and more orange, glows like a warm ember. Together they create a shared sphere of light, a dual sunrise for any worlds that might orbit them. We imagine standing on such a world, its skies painted with double shadows, its nights touched by the soft red flicker of Proxima far away. Even from this imagined horizon, our sun would appear as just another distant star, twinkling faintly in a sea of billions. And here, drifting between the 2 systems, we begin to understand something comforting. In the vastness of the galaxy, even stars have companions. Distance may stretch endlessly, but solitude is rare. The universe is wide, yes, but it is also full of connections waiting quietly in the dark. 4 light-years sounds almost small, until you try to imagine the space between here and there. Distance stretches like a cosmic desert, so wide that even beams of light need years to cross it. In this segment, we gently unfold the true magnitude of that gap. To begin understanding it, we slow our minds to the pace of the universe itself. Light, the swiftest traveler we know, races through space at nearly 300,000 kilometers every single second. It can circle Earth 7 times before you finish a single breath. And yet, even for light, the journey to Alpha Centauri is long enough that entire seasons would pass on Earth before its arrival. A child born the moment a beam of sunlight departs our solar system would be nearly old enough for school before that same ray reached the nearest stars. As we drift into the stillness of interstellar space, the scale becomes almost soothing. There are no landmarks here, no borders or walls, only a calm, uninterrupted expanse. The emptiness is not hostile, but gentle, like an endless, moonlit plain. Stars shimmer far behind us and far ahead, but between them lies a quiet so profound that it feels like floating through the pause between heartbeats. Imagine stretching the distance between the Sun and Earth just 8 light minutes, to the span of a long hallway. Now imagine walking that hallway for 4 years without stopping, and only then reaching the next doorway. That is what 4 light years represent. Not a road, not a route, but an ocean of time itself. Ships we build today would take tens of thousands of years to complete the journey. Whole civilizations could rise, change, and fade, while a single probe drifted slowly across this void. Even the fastest missions ever launched would barely graze the edge of the first light year after decades of travel. In this perspective, our technological steps appear tiny, but not insignificant. Every attempt is a whisper of intent, a promise that one day we will push further. As we imagine ourselves gliding forward, we begin to notice the texture of the space around us. The interstellar medium is thin, so thin that a single breath of Earth's air contains more particles than the volume of space we pass through in an entire lifetime. And yet, this near vacuum is humming with invisible energy. Photons from distant stars wander past us. Subatomic particles streak through the dark like silent raindrops. Magnetic fields ripple and twist, weaving patterns that stretch for trillions of kilometers. Occasionally, we drift past rogue wanderers, lonely comets, fragments of rock, or orphaned planets that escape the gravity of their home stars. They travel in perfect silence, carrying ancient stories of formation and destruction. Some have been adrift for billions of years, older than any mountain on Earth, older than the continents themselves. They remind us that even in the emptiest spaces, there is movement, history, and mystery. 4 light years is not just a measurement of space, it is a measurement of patience. It is the time required for light to tell one star about the existence of another. It is the quiet stretch where nothing rushes and nothing echoes. As we float through this vast distance, we feel its enormity, but also its calm. Between here and Alpha Centauri lies a desert of time, yes, but it is a peaceful one, where every moment drifts gently into the next. And in that drifting, we begin to understand the universe is vast, not to intimidate us, but to invite us into a deeper kind of wonder, one measured not in miles, but in the quiet, steady passage of light across the dark. We glide outward from the sun, past the warm inner planets, past the cold giants, until even Pluto shrinks into memory. The edge of the solar system appears not as a boundary, but as a fading echo, and beyond it begins the vast, silent sea we must cross. As we continue outward, the familiar architecture of our home system stretches like a map rolling open in slow motion. The sun, once a blazing presence dominating our sky, softens behind us into a warm, distant ember. Its solar wind thins, its influence loosens, and space becomes quieter with every million kilometers we drift. The planets we leave behind settle into their orbits like lanterns around an ancient hearth, each holding its own story, each now far too small to see. We pass the realms where comets sleep. Great clouds of icy bodies drift through the dark in numbers too vast to imagine. Some are the size of mountains, others hardly more than frozen dust. They circle the sun from distances so remote that a single orbit may take millions of years. These quiet wanderers form the Oort cloud, a spherical shell of icy relics surrounding the solar system like a ghostly halo. We drift along its edge, where sunlight is only a pale suggestion and temperatures fall to near absolute stillness. Here, time seems to stretch. The distances between objects widen until even light takes hours, then days, then weeks to cross what feels like empty space. But the emptiness is gentle. It welcomes us with soft darkness and a sense of unhurried calm. Every movement feels slow, deliberate, as though the universe itself is encouraging us to breathe deeper and let go of the familiar scale of home. Eventually, we cross the heliopause, the boundary where the sun's influence finally yields to the interstellar medium. It is not a wall, not a barrier, but a subtle shift, like stepping from warm water into cool air. Solar particles no longer dominate. Instead, we drift into the sea of the galaxy, where winds from distant stars begin to mingle with our path. In this place, the sun becomes just another star among billions. Looking back, we see our solar system as a tiny, glowing bubble adrift in a vast night. The planets, so enormous up close, now fit within a single point of light. The grand rings of Saturn, the storms of Jupiter, even Earth's bright blues and greens, all of them fold into a single luminous speck. The immensity of the transition settles over us. We have left not just a system of worlds, but the cradle of our entire cosmic identity. Ahead lies true interstellar space. No more planets, no more dwarf worlds, no more moons or stretched out orbits, only the quiet between suns. It is here that the scale of the galaxy reveals itself fully, inviting us to imagine distances not in millions of kilometers, but in years of light. And as we drift into this deeper dark, a gentle realization forms. Our solar neighborhood is vast, yes, but it is only the first step. Beyond its faint outer whisper begins a journey so immense, so peaceful, that the space between stars feels less like a gulf and more like a tranquil ocean stretching endlessly ahead. Launched in 1977, the Voyager spacecraft drift onward at a humble pace by cosmic standards. If Voyager were headed toward Alpha Centauri, it would take over 75,000 years. We imagine what that leisurely, ancient journey would feel like. Voyager moves not like a rocket, but like a leaf carried by the gentlest breeze. Its speed, staggering by human standards, becomes almost stillness out here, where distances swallow entire lifetimes. And yet, there is something profoundly poetic about this tiny craft, no larger than a small car, continuing its quiet glide through the dark more than 4 decades after it left Earth. It is a time capsule, a metal memory of our world, carrying whispers of who we were and what we dreamed. We imagine drifting alongside it, matching its patient pace. At this speed, Alpha Centauri is not a destination, but a horizon that would outlast civilizations. Empires would rise and fall, languages would change beyond recognition, continents would shift, even the face of Earth itself might be reshaped by ice, water, and time. Voyager, meanwhile, would continue forward, unhurried, unchanging, crossing the void with the serenity of something that has all the time in the universe. On board, the golden record spins silently, sealed in its protective case. Etched into its surface is the story of Earth, told through sounds, ocean waves, birdsong, thunder, laughter, the heartbeat of a mother and child. Music from across cultures drifts in this cosmic bottle. Bach and Beethoven, Navajo chants, ancient drumming, greetings in dozens of human languages. If Voyager is ever found, it will introduce humanity with a warm smile rather than a declaration of power. It carries not our weapons, not our fears, but our curiosity. As we travel with Voyager, the sun begins to shrink into the distance. Eventually, it fades into the background glow of the Milky Way, becoming just another faint beacon among countless others. The spacecraft has no engines firing, no bursts of acceleration, only momentum, a single push from long ago. Its endurance is almost meditative. It reminds us that movement through the cosmos does not always require speed. Sometimes it requires persistence. We glide past dust clouds and drifting particles, the slow currents of the interstellar medium brushing against Voyager's golden antenna. Temperature drops to unimaginable lows, colder than any place on Earth. Radiation storms occasionally wash over it like invisible waves. But the little craft continues on, unshaken. Even its instruments, now slowly fading, still attempt to speak to us across billions of kilometers, as though reluctant to fall silent. There is a quiet beauty in this endurance. Voyager is not racing anywhere, it is simply journeying. It is a message, yes, but also a metaphor for our species. Tiny, fragile, hopeful, moving outward into the unknown, because something inside us longs to understand. If Voyager were truly headed to Alpha Centauri, it would be a journey not of decades, not of centuries, but of epochs. And yet, in imagining that slow crossing, we feel no frustration, only calm, because in its patient drift lies a gentle truth. Even the smallest steps outward, taken with wonder, carry us toward the stars. New Horizons, one of the fastest ships ever built, hurries through space at 36,000 miles per hour. Yet even at this speed, Alpha Centauri remains tens of millennia away. Here, we explore why chemical propulsion simply cannot carry us to the stars. New Horizons moves with astonishing swiftness by the standards of human engineering. At launch, it surged away from Earth faster than any spacecraft before it. It crossed the distance to the Moon in just 9 hours, slipped past Jupiter in barely a year, and sailed onward to the realm of Pluto as though skimming across a cosmic lake. And yet, as we drift alongside it now in imagination, we feel something surprising, a sense of stillness. For all its speed, New Horizons is barely crawling across the galactic scale. At 36,000 miles per hour, it could circle Earth in under 40 minutes, but crossing the distance to Alpha Centauri would take nearly 80,000 years. If it were truly on that course, it would not arrive until long after the pyramids had weathered into dust, long after today's languages had dissolved into unrecognizable descendants, long after our species itself had changed in ways we cannot predict. To understand why, we slow the moment down and look at the fuel that carried it here. Chemical rockets, the engines that launched every spacecraft in history, burn their propellants in an explosive rush, pushing ships upward with fire and thunder. They are perfect for climbing out of gravity wells, leaping into orbit, and making swift maneuvers within a planetary system. But for crossing between stars, they are like candles trying to illuminate a continent. Their energy, though powerful, burns too quickly and delivers too little momentum for the vast emptiness ahead. Even the most advanced chemical engines release only a fraction of the energy locked inside their fuel. They must carry huge tanks, and once that fuel is spent, the spacecraft coasts forever with no way to speed up. Chemical propulsion is a sprinter, dazzling in its early burst, but exhausted almost instantly. The journey to Alpha Centauri demands a marathoner, something steady, persistent, capable of pushing for decades or even centuries without pause. As New Horizons drifts onward, the sun behind it shrinks into a pale star, and the gravitational embrace of our home system weakens until it is little more than a memory. Beyond this point, the spacecraft is a feather on the breeze, carried solely by the momentum of its initial leap. There are no more boosts, no more burns, no more corrections, just the long, patient glide through interstellar darkness. This limitation is not a failure of engineering, it is a reminder of scale. Chemical rockets were built for the worlds near us, for orbit. They are magnificent tools, but they belong to the era of our first steps, not our crossings between suns. If humanity dreams of reaching Alpha Centauri within a human lifetime, we must reach beyond combustion and flame. We must imagine engines that sip energy from the stars themselves, or push against the very fabric of space. And as New Horizons continues its quiet voyage into the deep, it serves not as a disappointment but as a promise. It shows us how far we've come, and how much farther we still yearn to go. A solar sail unfurls like a cosmic kite, catching sunlight instead of wind. In this segment, we drift alongside a hypothetical sailcraft, imagining decades of gentle acceleration toward a distant sun. At first, the sail seems almost impossibly delicate, thinner than a whisper, shimmering like liquid silver as it spreads across the vacuum. Instead, it opens into silence, embracing the gentle pressure of sunlight. Each photon that strikes it transfers the tiniest nudge, a push so small it would be lost in the chaos of any world with air. But out here, in the deep, perfect stillness of space, those nudges accumulate. The acceleration is soft, barely noticeable, like the slow curve of a dream taking shape. A chemical rocket might surge ahead loudly and then fall quiet forever, but a solar sail whispers forward with endless patience. Each day adds a little more speed, each year a little more momentum. Decade after decade, the sail gathers light as though it is drinking from a stream that never dries. We drift beside it, matching its serene glide, watching the sunlight reflect off its vast, shimmering surface. It looks almost like a floating leaf or a silvered petal carried by a wind we cannot feel. Behind us, the sun glows softly, still feeding the sail with its warmth. Ahead, Alpha Centauri waits as a faint point of light, a destination not approached by brute strength, but by gentle persistence. The craft is quiet, with no vibrations or mechanical tremors. The only sound is the soft hum of onboard instruments measuring the faint push of radiation. Inside, there is room for only the essentials: sensors, guidance systems, perhaps one day a few grams of human messages encoded into crystalline memory. A solar sail is all journey. Almost no payload, almost no mass. As years pass, the sail grows faster than any chemical rocket could hope to be. Its acceleration is constant, a faithful companion. Slowly, it leaves the planets behind. Mars shrinks to a red spark, then vanishes. Jupiter, once enormous and majestic, fades into the tapestry of stars. Eventually, even Pluto becomes a forgotten ember. The sun begins to look like any other star, bright, yes, but no longer dominant. And still the sail moves. One decade becomes two, then three. Out here, the craft knows no friction, no drag, no resistance. Its speed becomes something astonishing, not the furious burst of a rocket, but the patient glide of a dancer crossing a stage measured in trillions of miles. We imagine standing at the edge of the sail, our feet touching nothing, our bodies held in a cradle of infinite dark. The sunlight that reaches us is pale, but still enough to push us onward. When the sun's rays finally grow too faint to matter, perhaps powerful lasers from Earth or future colonies could continue the journey. Beams of energy guiding the sail like a lighthouse guides a lone ship at sea. In this way, the sail becomes a symbol of a different kind of travel. Not rushed, not forced, but aligned with the universe's own rhythm. It shows us that across the silence between stars, progress can be gentle and still profound. As Alpha Centauri brightens ahead, the message becomes clear. Sometimes the quietest engines carry us the farthest. Sometimes starlight itself is enough. Now we consider the boldest idea of all: tiny probes pushed to 20% the speed of light by Earth-based lasers. At that pace, Alpha Centauri becomes reachable within a human lifetime. We watch the concept unfold like a dream humanity is finally ready to chase. Breakthrough Starshot begins not with a roaring engine, nor with a towering rocket, but with a glimmer of imagination. An idea that the journey to another star might not require a massive spacecraft at all, but instead something small, swift, and astonishingly light. Instead of building a ship that carries fuel, we build one that carries almost nothing. Instead of pushing from behind, we shine a beam of light so powerful it becomes a wind. And instead of sending a vessel the size of a car, we send one no heavier than a feather. The probes, called star chips, are tiny wafers of electronics attached to fragile, shimmering sails. Each sail might stretch a few meters wide, but the entire craft could weigh just a few grams. So light that gravity barely notices, so delicate it could rest on your palm like a silver leaf. Yet these miniature explorers would be among the fastest objects humanity has ever created. We imagine the launch site, a vast field of laser arrays spread across the desert, silent until awakened. Then, in a moment, they ignite, not with fire but with pure, focused light, forming a beam hundreds of gigawatts strong. The beam strikes the sail, and the sail responds like a living thing, bending ever so slightly, glowing under the pressure. For a few minutes, the lasers push with relentless precision. The craft accelerates so quickly that within the time it takes to drink a cup of tea, it is already faster than any spacecraft in history. At 1/5 the speed of light, the probe becomes a streak of brightness, vanishing into the black faster than the human eye can track. After that, there are no more pushes, no more guidance beams, just the probe's own momentum carrying it across the emptiness between suns. We drift alongside this tiny traveler, imagining what it feels like to move at such an incredible speed. Stars shift subtly in the background. Interstellar dust grains, rare but real, flash past like faint sparks. Time stretches out into decades, yet the journey remains astonishingly brief for the scale of the galaxy. In just 20 years, the probe would arrive at Alpha Centauri, passing through the system in a quick, silent arc, snapping images and collecting data that humanity could never gather any other way. The thought is soothing in a strange way. Humanity, for all its complexity, could send something so small, so quiet, so unassuming, and yet achieve something monumental. Starshot is not just a technological challenge, it is a shift in thinking. It tells us that our path to the stars may not lie in massive ships carrying generations, but in lightweight explorers riding beams of light. In this vision, the dream of interstellar travel gently changes shape. It becomes cleaner, simpler, more graceful. For the first time, Alpha Centauri feels close enough to touch. Reachable not in mythic stretches of time, but in the span of a single human life. And as we watch the sailcraft disappear into the darkness, we feel the quiet hope it carries that our first message to another star may already be in flight before we ever open our eyes from this dream. To travel at such speeds, a ship must be almost weightless, a wafer of sensors and circuits thinner than a credit card. Here, we reflect on how small something must become to outrun its own limitations. In the quiet of interstellar dreaming, we picture this starship laid gently in the palm of a hand. It is not a gleaming monolith or a towering vessel of steel, but a sliver of technology so delicate it could flutter in a breath of air. And yet, within its fragile form lies the distilled essence of exploration. Cameras the size of grains of salt, processors thinner than a sheet of paper, antennas that fold like metallic spider silk. Every component is a whisper of engineering, refined to its barest, most essential form. The challenge is clear. To move at 20% the speed of light, mass becomes the enemy. Every gram carries cost. Every additional millimeter slows the dream. A starship for this journey must be not only small, but nearly immaterial, an attempt to travel faster by becoming almost nothing at all. We imagine the engineers who work on such a craft, bending over microscopes, shaping worlds within worlds. Circuits etched into wafers thinner than a fingernail. Sensors crafted from single molecules. Batteries replaced not with stored energy, but with the hope of capturing whatever power the universe offers freely. Light, heat, magnetic fields, or simply the charge carried in empty space. Even communication must shrink. A traditional radio dish would be impossibly heavy, so the starship becomes its own antenna, vibrating the fabric of space with the faintest possible signals, whispering across trillions of kilometers. By the time its message returns home, decades will have passed. The probe must speak softly, but clearly enough for Earth to hear. We drift beside this miniature traveler, marveling at how much meaning can be contained within something so small. It feels almost poetic. Humanity, a species known for building giant machines, now placing its greatest interstellar hopes in something lighter than a feather. The paradox is soothing. Our reach grows not by building bigger, but by shrinking beyond what seems possible. As we float with the tiny craft, we begin to understand the universe it must endure. At a fifth the speed of light, even a single grain of dust becomes a bullet. A molecule of stray gas is enough to strike with the force of a hammer. To survive, the starship must wear a shield no thicker than a thread of hair, yet strong enough to turn aside the invisible shrapnel of the cosmos. Heat will build. Radiation will whisper through its circuits. Decades of exposure will erode even the hardiest materials. And so, the craft must not only be small, it must be clever. Self-correcting, self-healing, able to reroute around damage like a tree finding new paths for its roots. It must endure not for hours or days, but years measured in the quiet rhythm of starlight. By the time the probe draws near Alpha Centauri, its body will bear the scars of its crossing, but its mission will remain, to turn toward the twin suns ahead, open its tiny eye, and record a view no living human has ever seen. In its smallness, it becomes immense, not in size, but in significance. It embodies a simple truth. Sometimes, to go farther, one must first become lighter. Sometimes to touch the stars, we must learn to travel as lightly as light itself. At a fifth the speed of light, even a grain of dust becomes a dangerous bullet. We explore how a star-bound craft might shield itself, perhaps with a thin sheet of plasma, or by riding just ahead of its own vaporized bow wave. Imagine drifting through a void that feels empty, yet holds invisible hazards. Each speck of dust, smaller than a grain of sand, strikes with the energy of a rifle bullet at these incredible speeds. The interstellar medium, sparse though it is, cannot be ignored. It stretches across light years, each tiny particle a potential threat, each collision a reminder of the delicate balance between speed and survival. Engineers and dreamers have imagined ways to navigate this perilous ocean. One idea is a plasma shield, a thin, ionized cloud that forms a protective bubble around the craft. As dust strikes, it vaporizes before reaching the fragile sensors inside. The shield is not heavy or cumbersome. It is a living extension of the ship, created from its own energy, flowing like a luminous halo that deflects the cosmic bullets in silence. Another concept is to use the craft's own bow wave. At such extraordinary speeds, gas molecules and dust ahead can be ionized and pushed aside, forming a leading edge that softens impacts. It is as if the ship carves a path through the void, leaving a tiny wake of cleared space behind it. The craft becomes both voyager and sculptor, shaping its own safe corridor through a universe that otherwise would tear it apart. We drift alongside the starship, imagining the sensations, or perhaps the lack thereof. There is no sound in the void, no vibration of engines, only the eerie glow of plasma and the faint traces of scattered particles. Collisions are sudden and invisible, each one a miniature spark that vanishes almost instantly. Time itself seems to stretch, measured not in seconds or minutes, but in the quiet interval between dangers. Even with protection, the journey demands patience and humility. The craft must endure decades of subtle bombardment, each speck of dust slowly chipping away at perfection. Its instruments must adapt, its circuits must reroute, and its tiny sensors must remain alert to every impact, every tiny fluctuation in the invisible sea it travels through. There is no room for error. Even the smallest miscalculation could deflect it off course by thousands of kilometers by the time it reaches Alpha Centauri. Yet there is beauty in the danger. The interstellar dust is ancient. It is composed of remnants of stars long vanished, material older than the Earth itself. Each particle carries a story, drifting silently across the galaxy, and our tiny starship becomes part of that story, a fragile observer threading its way through eons of cosmic history. As we glide along with the craft, it becomes clear, navigating the interstellar medium is not just a matter of shielding or speed. It is a dialogue with the universe itself, a careful negotiation between fragility and endurance, between motion and patience. The dust is both obstacle and witness, a subtle reminder that even in emptiness, the cosmos is alive. And so the tiny sailcraft continues, weaving through the unseen hazards, carrying humanity's hopes. Each grain it survives is a testament to ingenuity, a whisper that even across 1 trillion miles, we can endure and arrive. Between stars lies not emptiness, but a thin, cold haze of atoms and magnetic fields. Drifting through this dark ocean, we imagine the silence, the loneliness, and the strange beauty of interstellar night. In this vast space, time stretches and perspective shifts. The sun, once the center of all we knew, has become a faint pinprick of light. Every familiar landmark of our solar system has receded, leaving only the faint whisper of its memory. Here, between stars, the universe feels both immense and intimate, a place where the smallest particle carries significance and the darkness itself seems alive with subtle motion. The interstellar medium is sparse, yet it is never completely empty. Hydrogen and helium atoms drift for trillions of kilometers, moving so slowly that, to a starship, they seem almost suspended. Invisible magnetic fields ripple through this haze, creating currents that twist and turn across unimaginable distances. Light from distant stars bends subtly, creating a faint shimmer, as though the universe is refracting its own presence. To drift through this space is to float in a cathedral of silence, where every motion is measured and every instant stretches like a drawn-out breath. Even soundless, the void has texture. Tiny grains of dust, remnants of long-dead stars, streak past at tremendous speeds, unseen but felt by the craft as gentle jolts or sparks of radiation. Cosmic rays, energetic particles from distant supernovae, pass through like invisible streams of fire, bathing the starship in a subtle glow. In this expanse, the universe's scale becomes clear. Between suns, there is space enough for the mind to wander for lifetimes, yet the smallest forces, the push of a particle, the tug of gravity, can shape journeys across light years. The loneliness of this journey is profound. No other planets drift nearby, no familiar moons, no distant clouds of comets. Only the patient shimmer of distant stars and the dark currents of interstellar dust accompany the craft. And yet, in that loneliness, there is beauty. The silence is not threatening. It is meditative. It allows the mind to stretch, to imagine worlds far beyond our own, to feel the pulse of a galaxy moving quietly in the dark. We imagine the starship gliding through this void, carrying its fragile sensors and dreams. Every photon it collects, every measurement it takes, becomes a conversation with the universe. Each passing atom, each micro-collision, is a reminder of the vast scale of what lies between the familiar and the unknown. It is a place that asks for patience, respect, and awe, and rewards the observer with a perspective no planetary surface could ever provide. Here, drifting between suns, we begin to sense a deeper rhythm of existence. Distance is immense, yes, but the void is not empty. It is a living canvas of particles, fields, and light. And in that slow, measured drift, we feel the quiet reassurance of motion, the gentle progress of exploration, and the hum of the universe itself, patiently carrying us toward the next distant star. Travel fast enough, and time itself bends around you. Minutes stretch differently for traveler and observer alike. We explore the gentle, surreal effect relativity would have on a ship approaching a significant fraction of light speed. Imagine a starship racing toward Alpha Centauri at 1/5 the speed of light. From the perspective of those on Earth, the voyage will span decades. Years will pass, seasons will turn, civilizations will change, and the sun will drift across the sky as if impatient. Yet aboard the craft itself, time behaves differently. Clocks tick more slowly, hearts beat at a more measured pace, and the journey feels compressed, almost intimate. What seems long to an outside observer becomes a span of months or a few years for the traveler. This effect, predicted by Einstein over a century ago, is not science fiction. It is a real, measurable property of the universe. As velocity approaches the speed of light, every second stretches like soft taffy. Relativity gently reshapes perception, so that the faster we go, the smaller the world appears in duration, yet the distance covered remains immense. From inside the starship, Alpha Centauri draws near almost as if the universe itself is bending to welcome the traveler. We imagine the sensation. The stars ahead lengthen into streaks of light, subtle yet mesmerizing, as the craft slices through the darkness. Behind, the sun remains tiny, flickering faintly like a memory. Signals sent backward stretch, delayed by the vast emptiness and the warping of time, making communication a soft echo rather than an instant reply. The traveler experiences the journey as quiet and manageable, while Earth observes the relentless passage of decades. Even the most mundane acts, measuring instruments, data collection, simple moments of rest, are touched by relativity. Sensors must account for the stretching of time, while clocks tick with a gentle lag that is invisible but profound. Meals and rest occur almost normally, yet the universe outside flows on a different rhythm. It is a subtle, surreal effect. Motion itself warps the fabric of reality, reminding the traveler that speed is more than distance, it is a relationship with time itself. There is a poetic symmetry in this. While the galaxy stretches endlessly in the observer's view, it becomes smaller, more intimate for the voyager. The loneliness of space softens, replaced by a sense of intimacy with the stars, as if the cosmos has leaned forward to greet the traveler. The vastness remains, but relativity wraps it in a gentle embrace, allowing human-scale experience in a journey that otherwise would dwarf comprehension. We imagine the craft arriving at Alpha Centauri. To Earth, it has been decades. To the traveler, it has been months or a few short years. Time itself has played a quiet, invisible role, bending and stretching to make the impossible journey feel achievable. And in this bending of time, we feel a profound lesson. The universe is patient. It allows distance to be crossed not only through speed, but by the gentle curvature of time itself, inviting travelers to experience the cosmos in ways both real and deeply surreal. Imagine a starship propelled by tiny, controlled nuclear bursts, each explosion a spark pushing it forward. This segment reveals a propulsion method once considered science fiction, yet grounded in real engineering. We picture the craft as enormous yet elegant, a ship built to survive and harness tremendous energy. Behind it, a series of carefully timed detonations ignite, each one releasing energy far beyond anything a chemical rocket could achieve. The pulses strike a massive, resilient pusher plate, transferring momentum with precision. Each tiny explosion is a heartbeat, a rhythmic push that accelerates the vessel steadily toward the stars. Unlike conventional engines, this propulsion method is not limited by the weight of fuel carried in tanks. The energy comes from the bursts themselves, so the ship can grow faster and faster as it travels. In imagination, we see it climbing steadily out of the solar system, the pusher plate glowing faintly from each pulse, shock absorbers flexing with each controlled release. The soundless fireworks of energy ripple outward into the void, leaving trails of invisible force in the surrounding darkness. The beauty of nuclear pulse propulsion lies in its simplicity and audacity. It transforms the terrifying force of nuclear explosions, usually feared on Earth, into something delicate and purposeful when harnessed in space. It is a dance of destruction turned into creation. The raw power of the atom becomes a gentle hand, nudging humanity toward distant stars. The ship becomes a living rhythm, each pulse an echo of the sun's own energy, controlled, directed, and harmonious. We imagine drifting alongside the craft as it moves, each explosion imperceptible to the observer but profoundly felt by the vessel itself. Acceleration is steady. Unlike the brief thrust of chemical rockets, the starship gains speed over months and years, approaching fractions of light speed that would make interstellar travel conceivable within a human lifetime. From this vantage, the distance to Alpha Centauri begins to shrink, not physically, but in the perception of the mission. The impossible suddenly feels within reach. There is also caution in this vision. Each pulse must be carefully managed. Timing, alignment, and shielding are critical. Any misstep could damage the craft, yet the engineering is elegant enough to anticipate and absorb the forces. The vast pusher plate, the shock absorbers, and the controlled detonation sequence work in concert like a symphony, transforming explosive energy into patient propulsion. As the ship leaves the solar system behind, planets shrink into memory. The sun becomes a distant lantern, its warmth and light a gentle glow far behind. Between it and Alpha Centauri stretches the interstellar medium, thin, cold, and sparse. But the ship is undeterred, riding its chain of atomic bursts across the void. In this imagined journey, nuclear pulse propulsion becomes more than engineering. It is a statement of human courage, creativity, and willingness to harness the universe's raw power for exploration. Each spark is a promise that with ingenuity and patience, the stars are not unreachable. They are waiting for those who dare to ride the chain of energy across the silent ocean of space. A fusion drive would ignite hydrogen like a miniature sun, offering energy thousands of times greater than chemical rockets. Here, we drift into the promise and the challenges of harnessing starfire to cross the void. Imagine a vessel where the core glows with the controlled fury of a tiny star, each fusion reaction releasing energy with brilliance and precision. Unlike chemical rockets, which burn their fuel quickly and exhaust themselves, a fusion drive can sustain its output for decades, pushing a spacecraft steadily toward distant stars. It is not a burst of motion, but a steady, luminous climb, a gentle yet relentless acceleration into the darkness. The drive works by fusing isotopes of hydrogen, releasing immense energy in the process. Plasma streams are guided through magnetic fields, expelled as controlled jets that propel the starship forward. From a distance, the exhaust might appear as a faint shimmer, a miniature sun trailing behind, illuminating the void in quiet radiance. There is no roar, no tremor, only the elegant hum of energy converted into motion, a silent engine of cosmic ambition. We drift alongside such a craft in imagination, feeling the gentle pull of acceleration over years. Even at fractions of light speed, the ship moves with an almost meditative grace, gaining momentum steadily, as if space itself is yielding to its passage. Compared to the violent bursts of nuclear pulse propulsion, fusion drives are the embodiment of patience, turning the same forces that power stars into a vessel capable of bridging the yawning gulf between suns. But there are challenges as profound as the promise. Containing a miniature sun is no simple task. Magnetic confinement must hold the plasma perfectly, shielding the craft from the blistering energy it creates. Fuel must be carefully stored and injected, ignition precisely timed. Any instability could quench the drive or damage the ship. The technology stretches the limits of human ingenuity, demanding a harmony between engineering and the laws of nature that few have yet achieved. Yet the vision is compelling. With a fusion drive, the journey to Alpha Centauri could shrink from tens of thousands of years to mere decades. Time dilation may play a role for faster variants, subtly bending the experience of the crew or the instruments aboard. A voyage, once almost mythic, becomes tangible, a human-scale adventure across a sea of stars. We imagine looking back at the fading sun as the starship glides forward. The solar system recedes, planets shrinking to distant points of light, yet the craft carries with it the concentrated warmth of stars within its engines. Ahead, Alpha Centauri glimmers as a beacon, growing ever so slowly in the field of view, a promise of discovery made reachable by the fire we have learned to bottle. Fusion propulsion is not merely a method of travel, it is a symbol of possibility, that we might harness the same forces that light the cosmos to journey across it, that humanity can bottle the energy of stars and ride it into the silence between suns. In this quiet acceleration, we sense the subtle thrill of finally moving beyond our cradle, propelled by the light and fire of the universe itself. Antimatter annihilates matter with perfect efficiency. A teaspoon could power nations. In this calm segment, we explore what an antimatter starship might look like and why creating fuel is the hardest step. Imagine a vessel that carries within it the most potent energy source the universe allows: antimatter. Each particle is a mirror twin of the matter we know, identical in mass, opposite in charge. When the two meet, they vanish in a perfect burst of energy, leaving nothing behind but pure momentum and light. For a starship, this reaction could become the ultimate engine, transforming tiny amounts of fuel into unimaginable thrust. We drift beside such a craft in our imagination. Unlike ships propelled by fusion or nuclear pulse engines, an antimatter-driven starship has no need for vast tanks or colossal plates. Instead, it carries its fuel in magnetized traps, delicate cages woven from magnetic fields, holding the volatile particles suspended as if weightless. Each unit of antimatter sits like a caged spark, glowing faintly, promising power beyond comprehension. When the ship fires its engine, bits of antimatter are carefully guided to meet controlled amounts of matter. The annihilation releases streams of high-energy particles, channeled through magnetic nozzles that convert the energy into thrust. From the outside, the exhaust would appear as a thin, radiant beam, quiet, narrow, and unbelievably intense. There is no chemical flame, no roaring plume, only a blade of invisible power carving gently through the darkness. A ship like this could, in theory, reach astonishing speeds, perhaps 30%, 50%, or even more of the speed of light. Distances that once seemed unreachably vast begin to fold inward. Alpha Centauri, 4 light-years away, transforms from an eternal dream into a journey lasting decades or less. Inside the craft, the traveler would feel only the soft pressure of continuous acceleration, as if the universe itself were leaning quietly forward. But the elegance of antimatter propulsion comes with profound challenges. It is not the engine that resists us, it is the fuel. To produce even a single gram, humanity would need far more power than entire nations generate in a year. Storing it safely is equally daunting. Antimatter cannot touch the walls of its container. It must float, trapped in magnetic fields, stronger and cleaner than any built at scale today. Even a tiny failure in the confinement system would release catastrophic energy. And yet, there is beauty in the concept. Antimatter is not fiction. It appears naturally in thunderstorms, in cosmic rays, and in the violent hearts of galaxies. The universe itself crafts it effortlessly, scattering these mirror particles like rare gems through the cosmos. Our challenge is simply to gather them, or to learn how to create them with the same ease. We imagine the starship gliding forward, its antimatter stores shimmering softly like bottled lightning. Behind it, the sun becomes a pale memory. Ahead, Alpha Centauri grows brighter, as if calling the ship home. In this quiet journey, antimatter propulsion stands as a symbol of ultimate potential, the idea that one day we may learn not only to light a star, but to hold its opposite, its mirror, and use it to cross the vastest oceans of night. Some starships may not rush at all. Instead, they might carry entire generations, floating civilizations that travel slowly, steadily, letting centuries pass like gentle tides. We imagine life aboard such a drifting world. Picture a starship not as a single craft, but as a self-contained ecosystem. Homes, farms, schools, and parks stretch through corridors and domes, all designed to sustain human life across centuries. Children are born, grow, and age into adulthood entirely within the ship, unaware of the stars outside, until they arrive at destinations their ancestors first dreamed of. Time flows naturally here, measured not in light years, but in seasons, celebrations, and quiet moments of reflection. The ship hums softly with life. Air circulates gently, filtered through systems that mimic the Earth itself. Water cycles endlessly, nourishing gardens where plants grow, birds flutter, and sunlight streams through artificial skylights. The inhabitants move through routines, rituals, and work that maintain both the ship and the social fabric. Education is continuous, passing knowledge from one generation to the next, ensuring that the purpose of the journey, the mission to another star, is never forgotten, even as centuries flow by like a calm river. Outside, the void stretches vast and dark. Stars drift slowly past portholes, so distant that the mind struggles to comprehend them. Meteors, cosmic rays, and the interstellar medium brush against the hull imperceptibly. The ship moves with steady persistence, powered by engines that may take decades to bring it even a fraction of light speed. There is no rush, no urgency, only a patient glide across the darkness. Yet, life aboard a generation ship is not static. Social structures must evolve to support long-term stability. Families, communities, and governance adapt over centuries, guided by principles laid down by the first pioneers. Traditions form, and the story of the journey becomes woven into the culture itself. Music, art, and storytelling flourish in a way that mirrors the quiet continuity of the stars outside, tying the inner world to the endless expanse beyond the hull. Challenges are subtle but constant. Maintaining a self-sustaining environment requires careful balance. Food, energy, and resources must be managed across lifetimes. Psychological resilience is as vital as engineering, for generations will never feel the gravity of a planet, nor see the sky as earthbound eyes do. They live suspended between home and destination, a civilization afloat in the ocean of space. And yet, there is profound beauty in this slow passage. Time, instead of pressing urgently, unfolds gently. Birth and death, growth and learning, all occur in harmony with the journey. The stars outside are companions rather than goals, silent witnesses to lives lived deliberately. In imagining such a vessel, we begin to see that interstellar travel need not always be a race. Some journeys are measured not by speed, but by endurance, by patience, by the generations who will live, dream, and pass knowledge forward until the ship finally arrives. Across centuries, the voyage becomes not just a mission, but a way of life, an intimate conversation with the cosmos. Carried steadily on a quiet sea of stars, cryogenic sleep offers a different approach, freezing time for the passenger while the universe moves forward. Here, we explore the quiet serenity of a ship where everyone sleeps and the stars drift silently by. Imagine a starship where the hum of engines is the only sound, a steady rhythm echoing through empty corridors. The passengers lie in stasis chambers, suspended between moments, their bodies preserved in a quiet, frozen stillness. Hearts beat slowly, breaths are paused, and metabolism almost entirely halts. Time, for them, is suspended, decades, even centuries, passing outside while they remain in perfect stillness, untouched by aging, untouched by the passage of years. The chambers glow faintly, a soft light reflecting from smooth metallic surfaces. Cool fluids circulate, keeping each sleeper at a temperature just above absolute stillness. While sensors monitor every subtle fluctuation, the ship moves steadily through the darkness, its trajectory precise, its engines whispering energy into the void. Stars drift past in slow arcs, some flickering faintly, others stable and distant, painting the cosmos across windows that few awake eyes will ever see. The serenity of cryosleep is profound. There is no need for constant activity, no daily routines, no conversations or chores. The universe itself becomes a gentle companion, moving past the frozen travelers without disturbance. Cosmic rays pass harmlessly through shielding, dust glances off the hull, and interstellar clouds flow by silently. The ship drifts in a kind of cosmic meditation, its passengers existing in a liminal state between here and there, suspended in the stillness of a long journey. In this imagined voyage, the outside universe ages and evolves while the travelers remain unchanged. Decades or centuries may pass without awareness, and when they awaken, the ship's instruments, the view of distant stars, and the mission itself will seem nearly instantaneous. Cryosleep allows humanity to leap across light years without feeling the burden of time, turning a journey that would normally outlast generations into something experienced almost like a blink. Yet there is also beauty in the solitude. The passengers may sleep, but the ship itself carries life forward. Systems hum with quiet energy, computers guide navigation, and engines maintain precise thrust. The vessel becomes a living organism in its own right, sustaining the suspended human cargo while threading through the silent cosmic ocean. Time outside flows gently, almost ceremoniously. Each star a distant sentinel, each particle a quiet witness to the journey. We drift alongside the starship, imagining the still faces of those inside. Their dreams, frozen or perhaps empty, mingle with the unbroken passage of light across the void. And in this quiet, we sense a strange intimacy with the cosmos. The stars move past in gentle arcs, the universe continues, and human life waits in suspended breath, prepared to awaken and witness a galaxy only hinted at by the slow drift of light. Cryosleep is a pause, a quiet surrender to time, a gentle acknowledgement that even the vast distances between suns can be crossed with patience, calm, and trust in the journey itself. Artificial intelligence may reach Alpha Centauri long before humans do. Self-repairing, self-learning probes could drift for decades without tiring. We gently consider a future where humanity's first footsteps are taken by machines. Imagine a probe, sleek and silent, gliding through interstellar space. Unlike a human crew, it feels no fatigue, experiences no fear, requires no rest. Its sensors scan endlessly, its instruments analyze without pause, and its processors learn with a quiet diligence that grows over years. This is a traveler built not from flesh, but from circuits and algorithms, a first ambassador for humanity to the stars. The ship may be small, almost featherweight, yet capable of incredible feats. It can detect cosmic dust, analyze radiation, capture images of distant worlds, and adjust its own trajectory as needed. Each decision is made in microseconds, each repair performed with mechanical precision. It drifts patiently, aware of its mission but free from the distractions, fears, and limitations that accompany life aboard a human starship. As it passes through the void between suns, the AI probe becomes both observer and participant. Cosmic rays brush against its hull, interstellar gas flows by, and distant stars shift imperceptibly in the background. The machine experiences nothing as humans would, yet it measures everything, mapping the universe with a clarity that outstrips our own eyes and minds. Time stretches, decades pass, and the probe remains unflinching, a silent witness to the vastness of space. There is a quiet poetry in this form of exploration. While humans dream and age, machines may arrive first, opening the way for future generations. They may capture the first close views of planets circling Alpha Centauri, map the stellar winds of its suns, and relay data back to Earth. Signals crossing light years to reach us, patient echoes of a voyage we will one day join. The first footsteps of our species, in this vision, are not made of flesh and bone, but of metal, circuits, and code. The probe's autonomy allows it to adapt, survive, and even improve over the journey. Damage from interstellar dust is repaired by robotic systems. Unexpected conditions are analyzed and solutions implemented without delay. It learns from its environment, optimizing its path and instruments, a quiet student of the galaxy. Yet this early arrival by machines does not diminish human dreams, it enhances them. The AI becomes a guide, a scout, a storyteller sending back glimpses of a world we have never seen. Its work reduces risk, informs design, and prepares the way for our eventual passage. In a sense, the probe travels both alone and with us, carrying humanity's curiosity into the silent seas of the cosmos. We imagine watching it drift toward Alpha Centauri, a small, tireless traveler moving steadily through darkness. Each passing star, each whisper of radiation is recorded, interpreted, and sent back. And in this quiet, deliberate journey, we sense the first gentle touch of humanity's ambition upon the galaxy, proof that even before we arrive, our presence can be felt through the minds and hands of the machines we have created. AI-driven exploration is a meditation on patience, ingenuity, and foresight. It shows that the journey to the stars can begin even before we ourselves step aboard, that sometimes the first steps into the universe are taken not by humans, but by the companions we have built to carry our dreams. As we finally leave the sun's gravitational influence entirely, we pass through the dim halo of the Oort cloud. Comets sleep here like ancient seeds, waiting for a distant sunrise that may never come. We glide slowly through this vast, nearly invisible region, where icy bodies drift in frozen silence. Each comet is a relic of the solar system's birth, a tiny archive of dust, rock, and frozen gases preserved for billions of years. They hang in the darkness like lanterns that have long since gone out, their surfaces reflecting faint starlight, each one a whisper of history suspended in cold space. The Oort cloud stretches for trillions of kilometers, forming a spherical boundary around the sun that we are now leaving behind. From within the starship, the objects appear as scattered points, subtle hints of structure in a vast, empty sea. The drift is serene, almost meditative, as if time itself slows in this distant expanse. Gravity's pull from the sun has become negligible, replaced by the gentle tug of the galaxy itself. We imagine the comets slowly nudged by passing stars, by magnetic fields, or by their own tiny collisions. Some may eventually journey inward toward the sun, melting into brilliant tails, while others will wander forever through the cold darkness, untouched. The Oort cloud is a place of quiet potential, a frozen garden waiting to awaken only under rare cosmic circumstances. Passing through, the starship senses nothing but silence and shadow. No sunlight warms the hull here, no planetary gravity curves the path. Yet the spacecraft carries all that has come before, the hum of systems, the stored energy of long-planned journeys, and the dreams of explorers aboard or behind the machine. Each frozen comet, each tiny particle, is a reminder of how vast the void is, and how small yet capable the traveler has become. There is a gentle rhythm to this drift. The spacecraft moves steadily, not rushing, allowing centuries of ice and stone to pass slowly along its sides. Observations are made, instruments hum quietly, and the frozen wanderers of the Oort cloud are catalogued, photographed, and measured, their stories folded into the larger narrative of exploration. We imagine the sense of awe to witness objects that have remained unchanged since the solar system's formation, to pass by seeds of ice that might one day carry water, or perhaps even life, to inner worlds. The journey through this outer halo is a threshold. Beyond the Oort cloud, the sun is no longer a dominant presence, and the interstellar medium begins to take hold. Cosmic dust, faint magnetic fields, and sparse gas clouds mark the beginning of the true void between stars. Yet even here, in this cold and distant place, there is beauty, the memory of the solar system's formation, preserved in icy silence, reminding us of the fragile, intricate birthplace we have left behind. As we drift past these ancient comets, the sense of departure is profound. The sun's warmth fades into memory, and the infinite expanse of interstellar space stretches ahead. The Oort cloud, a silent halo of frozen time, is the last whisper of home, a quiet reminder of the long journey now beginning in earnest toward distant suns. This is the great expanse, the distance where the sun becomes just another star behind us. The journey quiets. Everything slows. We settle into the deep rhythm of travel between worlds. Imagine floating in a space so vast that even the familiar warmth of our sun is now a distant, pale glow. The planets we once knew have disappeared into memory, and the familiar structure of the solar system fades into an abstract pattern of distant light. Here, there are no points of reference except the stars themselves, scattered like faint lanterns across the black canvas of the void. The ship glides silently, moving steadily but almost imperceptibly. Every motion feels smooth, continuous, unhurried. There are no jolts, no turbulence, only the soft, endless hum of systems maintaining life, guidance, and propulsion. Outside, interstellar gas drifts past in whispers, and cosmic dust glimmers faintly in the dim starlight. The universe here is both enormous and intimate, revealing its vastness while inviting reflection. Time itself seems to stretch differently in this expanse. Days, months, and even years are felt less in the urgency of movement and more in the subtle changes in instruments, the slow drift of particles across sensors, and the shifting pattern of starlight. The journey becomes not a race, but a meditation, a slow, deliberate passage through the emptiness that separates one sun from another. In this gulf, even the smallest detail carries meaning. A passing dust grain, a faint signal from a distant pulsar, or the shimmer of a far-off nebula becomes a landmark. The mind begins to measure distance not in kilometers or light years, but in moments of attention, in the awareness of patterns and rhythms that are invisible closer to home. The traveler learns patience, and the universe seems to respond, rewarding quiet observation with subtle revelations. There is also a profound solitude here. The sun, planets, and moons are behind us. Nothing familiar remains within reach. Yet this solitude is not loneliness. It is a space of clarity, free from distractions, from gravity wells and planetary rotations. The mind can expand, drifting alongside the ship in thought and imagination. Every star ahead becomes a potential destination. Every photon, a messenger of the cosmos. Every moment, a quiet connection to the universe. We imagine the ship continuing for years, decades, maybe longer, its motion steady and unbroken. There is no hurry, only the gentle accumulation of progress. Distances that once felt impossible begin to feel intimate as the vessel moves through the silent sea of stars. The journey itself becomes part of the experience, an endless rhythm, a slow dance across the vast emptiness, teaching patience, perspective, and awe. In crossing the interstellar gulf, we realize that travel is more than speed or distance. It is the embrace of the journey itself, the awareness of motion through the quiet vastness, the rhythm of time passing differently for traveler and observer, and the sense that even in the most profound emptiness, there is profound beauty. The gulf between suns is not a void to fear, but a space to inhabit, reflect, and move gently across, one quiet moment at a time. After decades, or perhaps centuries, a faint double star begins to brighten. We approach Alpha Centauri A and B, two suns locked in a graceful orbit. Their light spills across the darkness like a promise finally kept. We drift closer, allowing our eyes, or senses, to adjust to this new, distant radiance. Alpha Centauri A shines with a steady, golden warmth, familiar yet subtly different from our sun. Beside it, Alpha Centauri B glows with a softer, redder light, circling its companion in a slow, precise dance shaped by gravity and time. Together, they form a delicate balance, a celestial duet unfolding in the quiet vastness. The stars are more than points of light now. They are luminous landscapes in miniature, casting faint illumination across the interstellar medium. Dust and gas, caught between the suns, glimmer subtly, catching the light in fleeting reflections that remind us how much the void itself holds in silent beauty. Even at these distances, the energy of these stars reaches out, gentle but insistent, as if greeting the travelers who have crossed so many years and light years to reach them. Our instruments, or perhaps our imagination, begin to detect planets circling these suns. Shadows hint at rocky surfaces, icy moons, and potential oceans. Each orbiting world holds a quiet mystery, a chapter of a story that humanity has only glimpsed from afar. For the first time, we sense the scale and intimacy of this neighboring system, the gravitational dance of two stars, the delicate arcs of planets, the potential for environments both alien and strangely familiar. Time seems to slow as we linger, drawn by the elegance of this stellar pair. Decades of travel dissolve in the presence of their light, and the journey, long and patient, finally converges into a single, radiant point of focus. There is a sense of arrival, yet not of completion. The voyage toward Alpha Centauri is itself a meditation, and reaching the stars is only the beginning of new discoveries, new questions, and new awe. We imagine the craft adjusting its course, preparing to explore safely within this binary system. Sensors track subtle shifts, engines make gentle corrections, and instruments collect light and particles that have traveled 4 years to reach us. The first close glimpses of another star system bring both knowledge and wonder, a reminder that the cosmos is vast, patient, and generous in its revelations. The beauty here is quiet and profound. The light of 2 suns illuminates the darkness not violently, but with calm persistence. It is as if the universe itself has waited, holding a gentle welcome for those who venture far enough, patiently unfolding the reward of vision and endurance. The double star is a beacon, not just in distance, but in the story of exploration, patience, and imagination that has carried travelers across the void. As we drift closer still, the twin lights of Alpha Centauri reflect the dreams of those who imagine such a journey. They remind us that even across incomprehensible distances, even after years and generations, the universe responds to curiosity and courage. Their glow is not merely a light in space, but a promise that the distant, the impossible, and the unknown are not beyond reach. They are waiting to be seen, understood, and cherished. Orbiting a small red dwarf, Proxima b may be rocky, perhaps even warm enough for liquid water. In this tranquil moment, we imagine drifting past the quiet, ruddy glow of the nearest star to our Sun. Proxima Centauri is modest in size, a quiet ember compared to its brighter companions, Alpha Centauri A and B. Yet its presence is intimate, almost gentle, a nearby neighbor whose light has traveled just over 4 light-years to reach us. As we drift closer, the star reveals subtle fluctuations, faint flares that pulse like a soft heartbeat across the darkness. Its red hue paints the surrounding space in a tender glow, bathing Proxima b and any other orbiting worlds in a calm, ruddy light. The planet itself is imagined in soft strokes, rocky landscapes, possible oceans, gentle winds brushing across its surface. Inhabitants, if life exists there, would experience a sun that feels both distant and warm, casting longer shadows and colouring the sky with hues of copper and rose. Even from afar, we sense the quiet balance of conditions that make this world remarkable. A planet poised on the edge of possibility, where water, air, and chemistry might converge to create life. The approach is slow and deliberate. Our sensors or imagination trace the star's motion and the orbits of its planets, charting gravitational pulls, magnetic fields, and subtle currents of plasma streaming from the star itself. Proxima Centauri's activity is gentle, yet dynamic, reminding us that even a small star possesses a power that shapes its system in unseen ways. Its light is a beacon across the interstellar gulf, a soft invitation to explore and learn. There is serenity in this moment. The ship drifts quietly, and outside the portholes, space appears almost tactile, with particles of cosmic dust reflecting faint red light. We imagine passing near Proxima b's orbit, watching its slow rotation, noting the glimmer of potential oceans, the sweep of its atmosphere, the quiet contours of mountains and valleys etched over eons. The experience is both intimate and vast, an encounter with a world that has existed in solitude for billions of years, now gently observed by travelers from another star. Time seems to stretch and slow here. The distance between stars has been crossed with patience, with technology, with imagination. Yet, in this red glow, we feel a pause, a quiet reflection on the journey itself, the first encounter with a sun that is almost a sibling to our own, yet profoundly alien. Every observation is a meditation, every spark of light a reminder that even the smallest star carries the depth and complexity of the universe within its influence. As we drift past, we sense the proximity of our closest stellar neighbor, not just a point of light, but a quiet presence, a reminder that the cosmos is filled with wonders both near and far. Proxima Centauri, with its gentle red glow, its orbiting worlds, and its patient, enduring light, invites reflection that even across vast distances, the universe offers moments of intimacy, quiet discovery, and the gentle reassurance that exploration itself is a journey as profound as the destination. The Alpha Centauri system holds worlds we have only just begun to glimpse. Some may be Earth-like, some barren, and some untouched mysteries waiting for future explorers. We drift imaginatively through the orbits of these distant worlds, seeing them as they might appear from a starship gliding silently through the darkness. Around Alpha Centauri A and B, planets trace precise paths, some potentially rocky, some gas giants, each carrying its own story of formation, its own silent history. From afar, they appear as tiny spheres, their surfaces hidden beneath clouds, ice, or shadow. But already, they hint at possibilities, at environments that might resemble our own or defy all expectation. Among the known candidates, Alpha Centauri, B-Flap, and others remain largely speculative, revealed only through subtle wobbles in their stars or the faintest dips in brightness as they transit their suns. Yet even these hints evoke wonder. Rocky worlds may harbour mountains and valleys carved over eons, oceans that reflect twin suns, and atmospheres that shift in currents across days and nights unfamiliar to earthly eyes. Other planets may be barren, sculpted by relentless radiation, winds, or gravitational strains, their surfaces frozen or scorched, silent witnesses to the power of stellar neighbours. Proxima b, the closest world in the system, suggests the tantalizing possibility of habitability. Its orbit brings it into the temperate zone of its red dwarf sun, where water could flow, ice could melt, and life, if it has emerged, might persist in forms alien to our imagination. We envision vast red sunsets, skies tinged with the glow of distant Alpha Centauri, A and B, and winds carrying whispers of distant heat and light across rocky plains. Even the barren worlds possess a beauty of their own. Deserts of ice, mountains of stone, and cliffs carved by gravity's slow hand over billions of years. From the perspective of a traveling starship, the system unfolds slowly. The planet's orbits reveal rhythms and patterns, a celestial choreography of gravitational pulls and orbital dances. Magnetic fields ripple invisibly, stellar winds brush gently across their atmospheres, and cosmic dust drifts between them like a silent veil. Each world is a note in a symphony, a small, distinct voice in the song of the stars, waiting for explorers to listen more closely. Yet much remains unknown. Telescopes on Earth can hint at composition, orbit, and potential habitability, but they cannot fully reveal surface detail or life's subtle traces. This unknown space, the places we can imagine but not yet see, is as rich and compelling as the known. It invites patience, careful observation, and the quiet curiosity that drives all exploration. As we drift past, the Alpha Centauri system becomes more than just a cluster of stars and planets. It is a laboratory of possibility, a gallery of worlds shaped by forces both familiar and alien. Each planet, whether Earth-like or barren, is a testament to the diversity of creation, a quiet invitation to future travelers to look, to learn, and to imagine what lies beyond the next horizon. In these first glimpses, we sense both humility and hope, that the cosmos holds wonders for those who journey patiently, and that every star carries secrets waiting to be discovered. Here, we gather everything we've learned. With present-day propulsion, a journey would last tens of thousands of years. We lay out these numbers gently, helping the listener grasp the scale without overwhelm. Imagine launching a spacecraft with the technology we possess now. Voyager 1, humanity's fastest messenger, travels at roughly 38,000 miles per hour. At that pace, it would require over 75,000 years to reach Alpha Centauri. The number feels abstract, almost impossible, yet it is a measure of both distance and the limitations of chemical propulsion. We consider it not as a failure, but as a reminder of the immensity of the cosmos and the patience required for true interstellar travel. Even New Horizons, which sped past Pluto at more than 36,000 miles per hour, would still take tens of thousands of years to arrive. These ships, remarkable in their own right, drift slowly against the backdrop of light years, their progress almost imperceptible on a human timescale. Yet in imagining them moving through the void, we begin to understand the vastness of space, the silent expanses that stretch between stars, and the quiet scale at which the universe operates. To make sense of these numbers, we picture years stretching like long rivers. A single human lifetime might pass, while a spacecraft barely clears the orbit of Pluto. Generations would rise and fall while the probe moves steadily through the Oort cloud, crossing the threshold into true interstellar space. It is not the failure of engineering, but the natural consequence of enormous distances, reminding us of both humility and awe. We also imagine the energy required to accelerate such a ship. Chemical rockets burn fuel quickly, yet even a full complement could only give the craft a fraction of the speed needed to shorten the journey meaningfully. The logistics, the storage, the mass, all combine to slow progress. And yet, this limitation inspires innovation. It is why concepts like nuclear pulse propulsion, solar sails, fusion drives, and antimatter engines exist not as fanciful dreams, but as potential solutions to the patience imposed by physics. In this reflection, the numbers become less intimidating. Tens of thousands of years is vast, yes, but it also frames our perspective. It reminds us that exploration is a long, deliberate act. Even at present-day speeds, progress is steady. Every mile traveled, every signal sent, is a small testament to curiosity and persistence. Time itself, measured against the void, becomes a companion rather than a constraint, flowing gently as the spacecraft drifts through the silent expanse. Finally, we imagine standing on Earth, watching the tiny speck of a distant probe journey outward. Its motion may be imperceptible, yet it carries the essence of human ambition. The journey may take tens of thousands of years, but in that span lies a quiet promise that even with today's technology, the first steps toward another star are already underway, moving patiently through the darkness, a gentle beginning to a far-reaching dream. Fusion, antimatter, or laser propulsion could cut the journey to mere decades. We explore the calm optimism of technologies being built today that may reshape tomorrow. Imagine a starship equipped with a fusion drive, igniting hydrogen like a miniature sun. Steady, powerful, and sustained. Such a ship could accelerate gently for years, reaching a significant fraction of light speed. The trip to Alpha Centauri, which would take tens of thousands of years with chemical rockets, could be reduced to a human lifetime, a span of decades rather than millennia. In our imagination, the stars draw nearer, and the journey, while still vast, becomes approachable, tangible, and almost intimate. Antimatter propulsion, too, promises extraordinary possibilities. A single teaspoon of fuel contains energy sufficient to power entire nations, and harnessed carefully, it could push a starship at unprecedented speed. The mechanics are delicate, particles trapped and guided, annihilation controlled, thrust applied with precision. Yet the concept is grounded in physics, and researchers have already begun the painstaking work of producing, storing, and managing antimatter at small scales. In this vision, the interstellar gulf seems less forbidding, and the idea of reaching another star within a few decades becomes plausible. Then there is Breakthrough Starshot, a bold, near-future concept. Tiny, wafer-like probes could be accelerated to 20% the speed of light by Earth-based lasers, reaching Alpha Centauri in just over 20 years. Though small and unmanned, these probes represent a proof of concept that human ingenuity can bend the rules of distance and time. In imagining them, we see the quiet poetry of technology and ambition combining to make the cosmos more accessible, turning impossible-seeming distances into journeys that could coincide with a human lifetime. Even at these speeds, the journey would remain profound. Time dilation, though subtle at fractions of light speed, would slightly stretch the traveler's experience, while the stars outside appear to blur and lengthen in their motion. The ship glides smoothly, steadily, across the silent interstellar medium. Cosmic dust, magnetic fields, and sparse gas clouds pass by imperceptibly. Yet every mile is a step closer to discovery. Every photon collected a messenger from a distant world. Near-future technology invites calm optimism. It reminds us that patience and creativity are our allies in exploration. The enormous distances between stars remain, Yet we now have tools that allow the mind to shrink them, the imagination to bridge them, and the craft to carry us across them within a human lifetime. The universe still hums with vastness, but our reach grows with each innovation, with each careful experiment, with each dream realized in the lab or observatory. As we imagine approaching Alpha Centauri at these faster speeds, the twin suns brighten, their light spilling gently across the darkness. The promise of fusion, antimatter, and laser propulsion is not only technical, it is a narrative of possibility, a testament to human curiosity, patience, and ingenuity. The stars wait patiently, and at last, we may travel to them while still keeping the rhythm of our own lives, moving through the void with quiet confidence and measured wonder. At 1% of light speed, Alpha Centauri becomes a 400-year voyage. We imagine a world of drifting gardens and quiet hallways, carrying humanity slowly across the dark. Picture a vessel vast enough to hold entire communities, self-sustaining and serene. Life unfolds within carefully designed habitats, sunlight simulated through artificial skylights, trees and plants growing in gentle cycles, water and air endlessly recycled. Families are born and grow up entirely on board. Education flows continuously, and traditions evolve as centuries pass. Outside, the stars drift slowly by, distant and constant, forming a silent backdrop to lives that move in rhythms entirely contained within the ship. Time aboard a generation ship stretches differently than it does for earthbound observers. A single year on board may feel familiar, while decades pass outside unnoticed. Children grow to adulthood, elders age, and new generations take their place, all while the ship steadily crosses the interstellar gulf. Life is continuous, predictable, and profoundly human. Yet it unfolds within a vessel, traveling through darkness that spans hundreds of light years. The ship itself hums with quiet energy. Engines provide gentle, constant thrust, just enough to maintain the steady pace of 1% of light speed. Systems monitor every aspect of the environment, from air composition to temperature, from nutrient cycles to waste management. Engineers and caretakers work quietly, ensuring that the ship remains habitable for centuries, that every mechanism operates reliably, and that the artificial world inside sustains its occupants across multiple generations. Outside, the void is vast but not menacing. Dust drifts past, faint interstellar gas stretches between stars, and cosmic rays pass silently through protective shielding. The darkness becomes a canvas on which human life unfolds, a slow, patient passage where each day is an opportunity for learning, creativity, and community. Even at this modest fraction of light speed, the journey requires endurance and foresight, yet the rhythm of life inside the ship is steady, comforting, and intimate. We imagine drifting through decades of stars, witnessing distant suns brighten and fade, watching planetary systems reveal themselves over time. The children born aboard may see the first glimpses of Alpha Centauri centuries after the journey began, their perspective shaped entirely by life inside the vessel. Yet for them, the voyage is not overwhelming. It is a natural continuum, a home that moves gently through space while generations live, dream, and pass knowledge forward. This vision emphasizes patience as much as speed. The journey at 1% of light speed may span 4 centuries, yet it allows humanity to travel safely and sustainably across the void. It teaches endurance, careful planning, and the profound ability to live fully within a moving world. In this slow glide, exploration becomes a lifestyle, and the stars are approached not in haste, but with quiet deliberation, allowing both the universe and its travelers to unfold gently together. At 10%, the journey shrinks to about 40 years, long, but within a lifetime. We reflect on the strange sensation of traveling faster than anything humanity has ever built. Imagine a ship accelerating to 1/10 of light speed. To the crew aboard, time feels familiar, yet the stars outside begin to shift differently. Light from distant suns stretches and tilts ever so slightly, the void itself appearing subtly compressed along the direction of travel. The universe seems to bend, offering a glimpse of the relativistic effects that govern high-speed motion. A silent, elegant reminder that physics guides even the boldest of human ambitions. Life aboard the ship continues in gentle rhythms. Days and nights are maintained artificially, with simulated sunrises, carefully regulated cycles of activity, and quiet moments of reflection. Crew members move through their routines, exercise in chambers, tend to gardens, and study the stars, all while the ship traverses the gulf between worlds at speeds previously unimaginable. The journey is fast enough to be thrilling, yet slow enough to preserve the continuity of human life. Outside, the interstellar medium passes swiftly, though imperceptibly compared to light. Cosmic dust, gas clouds, and magnetic fields are faintly visible through instruments, tracing the contours of the void. The twin lights of Alpha Centauri draw ever nearer, brightening imperceptibly at first, then gradually becoming a focal point in the distant sky. Traveling at 10% of light speed, the stars are not just points, they are destinations approaching with remarkable certainty, each day bringing measurable progress across light years. There is a curious tension aboard. The ship moves faster than any craft humanity has ever built. Yet relative to the vast distances, progress is still deliberate. 40 years may encompass an entire career or family lifetime, but across the cosmic scale, it is a blink. The crew becomes a bridge between human experience and interstellar immensity, living in a suspended rhythm where the voyage itself is as meaningful as the arrival. Time dilation remains subtle but present, stretching life very slightly for the crew relative to those left behind on Earth. Letters, signals, and observations sent home arrive years after departure, softening the separation while marking the unrelenting passage of light through space. The universe feels both vast and intimate, the travelers suspended between worlds, witnessing the profound interplay of distance, speed, and time. We imagine the quiet exhilaration of approaching Alpha Centauri A and B after decades of steady motion. The twin suns shine as a reward for patience, ambition, and careful engineering, their light spilling gently across the void. At 10% of light speed, humanity experiences something unprecedented: the ability to cross star systems within a lifetime, to see distant worlds grow from faint points into real, tangible places. This journey blends awe with reflection, velocity with serenity, traveling faster than ever before, yet slowly enough to savor the passage. The starship embodies human courage and curiosity. It teaches that even at a fraction of light speed, the cosmos remains vast, the journey profound, and the experience transformative, a lifetime stretched across the darkness, guided by the quiet light of distant suns. With starshot-like propulsion, the crossing becomes a mere couple of decades. That's the first time Alpha Centauri becomes a destination for the young and the determined. Imagine tiny, wafer-thin probes, or perhaps the beginnings of human-crewed vessels accelerated by Earth-based lasers to 1/5 the speed of light. Suddenly, the distant stars are no longer untouchable points in the sky. Decades, a single human lifetime, are enough to cross the gulf that once required generations. The cosmos shrinks gently, becoming a reachable, almost intimate stage for human curiosity and courage. At these speeds, the view outside changes subtly. Stars ahead appear slightly compressed, the light shifting as the ship moves through space with unprecedented swiftness. Interstellar dust and particles become significant considerations, striking the craft with tiny but important impacts. Shields, careful navigation, and innovative materials all play a part, transforming what was once purely imagination into tangible engineering reality. The journey is fast, but not reckless. It is deliberate, measured, and awe-inspiring in its precision. Inside the vessel, life takes on a rhythm that blends urgency with calm reflection. Decades pass, yes, but within the ship, days remain familiar. Sleep, exercise, study, and contemplation continue, all while humanity hurtles across the void. Even for crewed missions, time remains manageable. A young explorer may depart as a child and arrive as an adult, able to witness the first light of a new sun, the first glimpses of alien worlds, without centuries separating them from Earth. The twin suns of Alpha Centauri A and B gradually grow brighter in the forward viewport. Their steady glow, once a distant promise, becomes a tangible presence, a reward for decades of careful planning and patient acceleration. If the craft includes instruments or miniaturized explorers, planets around these stars begin to emerge in images, hints of surfaces, potential oceans, or ice-covered worlds, each offering new mysteries and possibilities. The arrival feels personal, almost intimate, because it is achieved within a human lifetime. There is also a profound emotional resonance in this speed. For the first time, the cosmos is not just observed remotely, but engaged with directly. The journey transforms from abstract to experiential. The void is crossed, the stars approached, and the unknown drawn near. Travelers can dream and act in real time, witnessing milestones that were previously the realm of imagination or the slow patience of unmanned probes. Even as the destination nears, the sense of motion remains humbling. Light years are crossed in decades, yet space itself is immense, filled with quiet dust, radiation, and magnetic fields that remind us how carefully and thoughtfully this progress must be undertaken. The adventure is both exhilarating and contemplative. Rapid motion paired with patient observation, speed combined with reverence for the universe we are entering. At 20% of light speed, Alpha Centauri is no longer a distant idea. It becomes a reachable goal, a place where determination, ingenuity, and courage converge. The journey is a statement that human ambition, carefully guided, can traverse the void, turning light years into decades and transforming distant stars from points of wonder into destinations waiting to be explored. If technology someday reaches this frontier, the star becomes only a handful of years away. Here, we glimpse a far future where crossing between suns becomes routine. Imagine a starship accelerating to half the speed of light, slicing across the interstellar gulf with astonishing swiftness. The sun fades rapidly behind, shrinking to a faint point among countless others, while Alpha Centauri brightens ahead, its twin suns growing from distant sparks into radiant beacons. In this realm, the journey that once demanded decades or centuries now unfolds over mere years, compressing the vastness of space into a human experience almost tangible in scale. Time behaves differently at these speeds. Relativistic effects become noticeable, stretching and bending the perception of events. To those aboard, the passage of light from distant stars seems subtly altered. The universe ahead appears contracted, slightly foreshortened, while the voyage itself feels almost immediate compared to the lifetimes once required. The mathematics of physics become palpable, a quiet reminder that speed changes not just distance, but the very experience of time. Life aboard such a craft would merge familiarity with wonder. Days would continue in gentle cycles, meals prepared, plants tended, and routines maintained, yet the outside world would transform with every passing moment. The stars, once distant, sweep past at an accelerated rhythm, a cosmic ballet now visible in real time. Instruments record the interstellar medium, detecting particles and radiation, mapping the subtle influences of gravity and magnetic fields that fill the void between suns. The approach to Alpha Centauri becomes a slow crescendo. Its twin suns, A and B, grow brighter with each week, their light painting the forward hull in warm gold and soft red. The planets around them, long imagined and studied from Earth, now appear as tangible spheres. Proxima Centauri glows nearby, a smaller, reddish sentinel whose potential world, Proxima b, hints at the possibilities of alien habitability just a few light years away. At half the speed of light, the experience of travel transforms human imagination. The journey itself is no longer measured in lifetimes or generations. It is an adventure, a continuous act of exploration, a series of days, months, and years that feel both fleeting and profound. Travelers witness the vastness of interstellar space intimately, noting the quiet beauty of cosmic dust, faint gas clouds, and distant stars, all passing swiftly yet elegantly alongside. This speed also evokes a sense of routine possibility. No longer is interstellar travel a rare or distant dream, it becomes part of a foreseeable future where humanity moves deliberately between suns. The distance that once imposed patience measured in centuries is now crossed within a few years, opening the door to exploration, colonization, and the quiet observation of worlds only hinted at from afar. We glimpse, then, a future where the extraordinary becomes ordinary. To move at half the speed of light is to harmonize human experience with the cosmos, blending life, motion, and discovery into a seamless journey. Alpha Centauri is no longer a distant star to wonder at. It is a destination within reach, a place whose light can be touched, studied, and perhaps even inhabited within a single human lifetime. The faster we go, the harder the journey becomes. Dust grains, radiation, and navigation hazards must all be overcome. We explore these dangers with calm clarity. At speeds approaching a significant fraction of light, even the smallest particles of interstellar dust become formidable threats. A grain of rock, smaller than a pebble, strikes with energy capable of piercing shields or damaging sensitive instruments. Space, once thought of as empty, is instead a field of potential hazards, silent, invisible, and relentless. The solution is both practical and elegant. Shielding layers, magnetic deflection fields, and precision navigation work together to protect the craft, allowing it to glide safely through the cosmic flow. Radiation is another subtle but persistent challenge. Cosmic rays, high-energy particles streaming from distant supernovae, bombard the ship relentlessly. Solar flares and gamma bursts add sudden, unpredictable bursts of energy. Shielding is essential, but it is not just physical. Careful design, orientation, and even the use of onboard magnetic fields can create a protective cocoon, softening the impact of the universe's relentless activity. The ship becomes both explorer and sanctuary, a vessel of life that must respect the invisible forces around it. Navigation itself becomes an intricate art. At high velocities, the tiniest miscalculation can be magnified across light years. Stars shift subtly in position, gravity tugs gently but persistently, and unseen objects, rogue planets, small asteroids, or denser clouds of gas, must be accounted for. Advanced sensors, autonomous decision-making systems, and predictive algorithms guide the craft, continuously adjusting its trajectory to avoid hazards. The pilot's role is transformed from manual control to careful oversight, watching as intelligent systems interpret the universe in real time. Yet these challenges are not insurmountable. They are met with ingenuity, patience, and design. Every risk is quantified, every particle considered, every radiation spike modeled. Engineers, physicists, and explorers collaborate across time and space, ensuring that the vessel, whether a tiny probe or a human-carrying starship, survives the journey intact. The process is meticulous, almost meditative, transforming the dangers of high-speed travel into a testament to foresight and preparation. In imagining this passage, we sense both tension and tranquility. The void seems perilous, yet the ship moves with quiet assurance. Cosmic dust glimmers in the faint starlight, invisible hazards are neutralized by careful design, and radiation pulses harmlessly against magnetic shields. The dangers are real, but the measures taken to meet them are equally real, creating a harmony between human ambition and universal forces. High-velocity travel, then, is not merely a question of propulsion or speed. It is a careful negotiation with the environment of space itself. Each threat teaches us respect for the cosmos. Each precaution demonstrates ingenuity, and each successful adjustment reinforces the quiet confidence of exploration. By understanding these dangers with clarity, we glimpse the delicate balance between risk and discovery, realizing that even at incredible speeds, the journey can be safe, controlled, and profoundly awe-inspiring. The faster we go, the more the universe demands of us. But the rewards of mastery are equally great. The void is challenging, yet navigable, and the voyage to Alpha Centauri continues, guided by insight, care, and the quiet courage of those who dream to reach the stars. Even light needs years to travel between stars. Sending messages back home becomes a slow, patient act, like mailing letters across galaxies. Imagine typing a simple message aboard a starship bound for Alpha Centauri. Even if transmitted at the speed of light, it will take over 4 years to reach Earth. The reply, sent immediately, will take another 4 years to return. A conversation, as we know it, transforms into a measured exchange across time and space. Each word, each piece of information, is received with the weight of years behind it, creating a quiet, reflective rhythm to communication. This delay reshapes human perception. The urge for instant answers, the expectation of immediate feedback, fades. Decisions must be made independently. The crew, or autonomous probes, must act with foresight, relying on knowledge, careful planning, and trust in their systems. The stars themselves become silent partners in this dialogue, carrying our signals faithfully across the void, yet demanding patience from those who send them. The messages themselves take on a different character. A simple report about the ship's progress, a description of a passing star, or a measurement of cosmic dust becomes a record of history. By the time the words reach Earth, conditions may have changed, yet the message preserves a moment, a snapshot of exploration frozen in time, traveling patiently across the light years. Communication transforms into an art of anticipation, reflection, and the careful sharing of knowledge. For human crewed missions, this creates a profound emotional dimension. Families, friends, and colleagues on Earth receive news delayed by years. A child born on Earth may read a message from a parent decades into the voyage, and the parent receives news of events long past. The passage of light imposes a gentle patience, blending human life with the immutable speed limit of the universe. Each message becomes precious, its arrival a small celebration, a quiet tether connecting distant travelers to their homeworld. Even for unmanned probes, delays demand autonomy. Decisions must be made on board without real-time guidance. Instruments operate independently, analyzing, recording, and responding to conditions. Every signal sent is carefully crafted to maximize usefulness, every observation meticulously timed. The universe teaches us to plan, to trust our systems, and to respect the interval between action and feedback. Yet within this slowness lies a subtle beauty. Messages drifting across the void become carriers of intent, curiosity, and human presence. They are physical traces of thought, moving faithfully through the cosmic expanse, connecting stars separated by unimaginable distances. Patience becomes a companion, and anticipation a quiet form of wonder. Communication across light years reminds us that distance is not just a measure of space, it is a measure of experience, reflection, and connection. Each message is an act of faith in the persistence of life and knowledge, a gentle affirmation that even across vast, silent distances, humans can reach out, share, and be remembered. In this slow, patient correspondence, the universe itself becomes a medium for contemplation, and the journey to Alpha Centauri is experienced not just in motion, but in the enduring dialogue of light. We begin coming back to shore after a long, slow voyage through thought. Tonight we measured a distance that once felt impossible. 4 light years, a space so wide it reshapes how we count our days. We traced the slow drift of Voyager and the urgent promise of laser-pushed wafers. We unfurled imagined solar sails, listened to the soft thumps of hypothetical nuclear pulses, and peered into futures where fusion and antimatter turned shipyards into small suns. We held the steady, patient vision of generation ships and the hush of cryosleep. We met the practical ghosts of interstellar dust, the quiet cruelty of radiation, and the tender paradox of time, how speed can stretch a life differently for traveler and home. All of those possibilities, from the cautious to the daring, are threads woven from the same human impulse, curiosity. That longing to know another sun up close is not a demand for conquest. It is a hymn of wonder. If nothing else, this journey reminds us that our reach is made of ideas, instruments, and the stories we tell one another before sleep. Tonight, beneath the familiar constellations, allow yourself a gentle gratitude for being part of this unfolding story. Feel how rare it is to be a listener, a thinker, a brief life on a small, bright planet that can imagine the dark between stars. Let that gratitude widen like the sky, for the warmth of our own sun, for instruments that translate whispers from distant worlds, and for the quiet courage it takes to keep asking. You do not have to cross the void to be part of the voyage. Your breath, your attention, your dreaming, these are the first small engines of exploration. Lay your head down, breathe in slowly, and breathe out the day. Let the image of two distant suns settle like a soft light behind your eyelids. Sleep now, traveler. The stars will still be there when you wake.